Happy to be here. My name is Marcelo. I work with Aurora. Today I hope you are up for some code. I do want to show you one of the neat functionalities that I think have not been exploited that much still on Aurora. And it's the very fact that Aurora is a smart contract on NEAR. It means that it can interoperate easily with every other NEAR contract out there without needing any bridge. So today I just want to deploy a very, hopefully I have internet. I've seen the internet here is not great, but hopefully with my cell phone I can share it. To show you a contract, like how we can connect a contract on NEAR to a contract on Aurora so they can talk between each other. I already made this very two simple and small smart contract. There is this status message contract on, sorry, not modes, that's insane. This is smart contract on, well, this is a Solidity smart contract, but this is a smart contract that you can run in Aurora. It's a kind of short smart contract. It's a little bit lengthy just because of public interface just to talk to it. But the main point is that you can call set Aurora address, and if you call this function, you will set a status message, like if it were your WhatsApp status or whatever. It's just a demo, not really important what it does. And then we will have this NEAR contract that I'm calling NEAR proxy, also simple contract, that if you call the set message, you notice that this is coded in Rust, no Solidity. So basically, just by calling this contract on NEAR, you will be able to interact with the status message on Aurora, and you will be able to set your status, but as a NEAR user rather than as an Aurora user. Okay? That's the whole point of it. So please, let's do it together, and then in the end, if you have any questions about how this is working, I'll try to show you a bit of the code and also explore to make sure that we understand how this works. Let me quickly share the internet. I think I should have internet with my phone. Yes, I have. Okay, perfect. So, sorry. We are going to status message. Okay. So first we're going to do is I made in this Solidity contract, I made three functions that we will be using today. One is to deploy the contract, one is to check all status message for every contract out there, and one is to just add a status programmatically. No interfaces, just CLI. Hopefully this will work for you. You will notice this is just hard hat. So interacting with Aurora, it's seamlessly the same. You would do it as interacting with Ethereum. Nothing fancy to it. So let me go through it. Before I will be using NEAR testnet and Aurora testnet just to avoid interacting with mainnet and real tokens, just because it's a little bit easier here than setting up secret keys and everything. So first thing is I will actually deploy NEAR contract. You can, this is just building the contract. It's super fast because I already built it before coming here, but building the contract is just building a Rust contract into WASM. And then deploying a contract in NEAR testnet, it's also just calling, you can use it with a CLI, and it's extremely simple. Okay, this seems to be working. On testnet, you get automatically assigned an account. We got this def1658, whatever, with some tokens into it. And right now we deployed our contract and we just initialized it with this function. Okay, so I was doing this before because right now I can just I have this new account that I will be using to initialize my Aurora smart contract. So the whole point is that on Aurora, just to show you a little bit about the Aurora smart contract, how it will work, we have these two functions, set Aurora address status or set NEAR account ID status. We can set a status as an Aurora user or as a NEAR user. Okay, and as a NEAR user, there is only one contract that can talk with my particular contract, and then every user can interact with my contract through this other contract. This is just how I designed this app. Doesn't need to be necessarily like this, but it makes it significantly easier. I will be sharing this code in GitHub afterwards. Okay, so if we just go here, we can, jar hard hat deploy, and I'm just deploying my contract. And there is something weird happening here that I'm specifying like near proxy account ID. This is the account on near that it's authorized to talk in behalf of near contracts. And here is a very neat part. On Aurora, we cannot, we don't have this concept of near account IDs, but we do have the concept of implicit address for near account IDs. So basically, for every account ID on near, there is an address on Aurora that will represent you every time you interact with Aurora as a near account. So that's really neat. In this case, for example, just to show you, this is my near account ID. It's a little bit cryptic in this case because it's a testnet address. You will usually have, I don't know, Marcelo.near. That's a near address. And then for every address, you will have an implicit account ID that it's derived deterministically, okay? So every time I will be talking with Aurora from this address here, I will be using this address in Aurora. So that's what I was specifying to initialize my contract. And right now, it's already deployed. So let me just hard code here, not here, here, the address of the contract. So I can easily list all the messages, all status messages. There is, of course, there is nothing there, but I can say, I can put some status here. I'm talking on behalf of my, of the same deployer, I'm using a testnet account to deploy, to interact with the chain. This is a regular output. Use a successful transaction on Aurora network happening, so you should be able to get this hash function and go maybe to testnet Aurora scan, and here in testnet Aurora scan, you will find this transaction. This actually took place on chain, and this was setting this was setting a status, right? So if I list all status right now, there should be at least one, okay? There is one status, and it's like, hello, EthCC. Okay? So right now I want to do the same thing, but from the near account, just to show how simple it is, and then what's happening under the hood. So from near account, first of all, I need to tell to the near contract, which is already created. I did, in the first step, I deployed a near contract. I want to tell the near contract that this is the contract it should be interacting to inside the Aurora network. So for doing that, there is this function. Let me just quickly show it. Set status message address. There is just a function that will tell the near contract, okay, this is the contract on Aurora that you care about. You'll notice that there is a little bit of boilerplate here, but this is only about initialization. I'm just going through the whole process with all of you right now. So set status message address, and I will set the address that we care about, no 0x, use hexadecimal. And this is a real contract on near blockchain that's taking place right now. You can see the transaction also on Testnet Explorer, and I'm setting what's the address that I care about, okay? So now, the cool part is that I'm setting a message, okay? So I'm just calling, I'm calling this contract. This is a near contract, okay? If I just call, account. This is the contract I'm interacting to on near blockchain. It's this kind of cryptic contract. And I'm just calling it from an account of my own, which is called ide.testnet. So I will set a status message from ide.testnet, and hopefully it will be set, not this, set message. Okay, so I will be calling the account of the contract on near, and to setting my status on the Aurora smart contract, okay? So super cryptic stuff happening here. The fact is that Aurora will spit out a few bytes that we don't need to understand right now. The point is that this is a successful transaction that took place, and if we go to the transaction and see what happened, you will see that there is a transaction that was created by ide.testnet, which is my account, I was calling the account that I just deployed, which will be working as the proxy between IDE and the account on near. And then you see, okay, I'm setting this message, and then this contract here is making a call to Aurora contract. Okay, and it's calling Aurora contract with the right parameters to set a status message on behalf of IDE.testnet. So if we go back to the part of IDE.testnet and I call list messages, you will see here, okay, there are two status already set. The first one is the first we set, with hello EthCC, and hopefully, okay, there is a second status. It's coming from IDE.testnet. This is an Aurora call, so this is right now me interacting with Aurora. And you see like a status of IDE.testnet, it's hello from near chain. Okay, so just to show a little bit of what is happening here, it's a really simple function that I'm calling. There is a little bit under the hood that I'll show you, but basically the core part is that we are making a cross-contract call where we specify which contract we want to call, how many like how many ETH we want to pass it. Right now, no ETH at all, we don't care about it, it's just 0. And then we encode the arguments of what we want to do. We are using the same format that Ethereum is using, because that's exactly what Aurora supports. It's an ABI encoding. And right now, I did all the encoding by myself, just by hand here. Okay, yes. This is how I'm coding, like I'm calling this function, set near account ID status. So I will not go deep into ABI, but we can discuss it later if you are interested. Here it's me just building by hand the arguments, and then the particular call, it's serialized in a very special way. That's why I wanted to create this repository and share it with people that it's actually interested in this kind of functionality. But while it's very particular, the format it's not hard at all. So we're making a near promise, and we're serializing the arguments that we're passing to this cross-contract call exactly as Aurora contract is expecting it. So we're calling the function call inside Aurora with these arguments. You serialize it as expected by Aurora, which is just serialized in Burst format used by near. Okay, so that's pretty much what I wanted to show to you. Hopefully it's interesting, and well, if you have any questions, feel free to ask.